everybody. Thank you for joining us. And today I like to open with a talk about hardware for vision on the edge systems. How can we accelerate hardware development, especially with a focus on AI on the edge? But before we start, a very short introduction of Phytec to give you a bit of a background. Phytec comes from embedded design in general. That's what we have been doing for 40 years now. And for 30 years, we also have a team specialized for embedded vision. So our main business is designing hardware for embedded systems, from system on modules, single board computers, to fully customized systems. And software-wise, we're designing the matching board support packages, mainly Linux operation systems, which also contain middleware and custom adaptations. And we offer a lot of services around embedded systems. So our goal is to offer one-stop shop solutions for professional applications. So today's topic is vision on the edge. And typically, we deal here with applications where vision is integrated inside a certain product. Yeah, you have a great idea for a vision product, maybe with AI on the edge, and you need a hardware platform to run your application or your models on. And the challenge is now to adapt the hardware to the requirements of your specific product. The question is, how can we design a new vision on the edge product with minimum effort? So one of the approaches that you might know already is the make and buy concept. The basic idea is to use ready-made modular components, a system on module, and off-the-shelf camera modules. That's the components here and here. And the individual part of the hardware is covered by designing a customized application board. And this already reduces the complexity of the design. The modules are proven and verified designs, so that's also reducing the design risks. Another benefit we have here with the software, with the CPU module, we get a ready-to-use Linux operation system that has been adapted to the hardware already, so-called board support package. And software development can focus on designing the actual application software. And later, when the product is in production, Phytec supports lifecycle management. We do the product change management for the modules. So that's off from the list of things you need to worry about. The same with the Linux operation system. Phytec provides frequently updates for the BSP, so that's something you won't need to care about neither. Now, this is a proven concept for many years now. Still, there is the challenge to develop the custom application board. And today I like to talk about how can we further reduce the design expenses, time and costs, for the custom part of the hardware. So for our new approach to reduce the development efforts, we have analyzed many projects to see which parts are typically used in all designs and which truly need to be specifically customized. And according to this, we designed a new phyVIP vision integration platform. The platform consists of a ready-made phyVIP baseboard, which carries all the components that are typically the same in a vision on the edge design. The heart of the baseboard is SOM, system on module, with either an NXP i.MX95 or i.MX8M Plus processor. By the use of the SOM, we can profit from the proven and verified hardware, as I just mentioned, and also have an upgrade path available for future designs. The phyVIP baseboard allows direct connection of two camera modules. The connection is done by a flat foil cable so that the cameras can be placed virtually anywhere inside the custom product. And just to give you an idea about the size, the phyVIP baseboard has about the size of a credit card. So now, how to customize the system? You might have noticed that the phyVIP baseboard has no connectors beside the two camera inputs. And this is because we have noticed that especially connectors need to be tailored in a custom project. And therefore, the phyVIP baseboard is complemented by a project-specific connector and expansion board. And this board is attached to the baseboard like a sandwich design. So on this board, the system designer has the freedom to place the connectors as required by the application. And of course, he can choose the type of connectors. If there are any very specific features required for an application, they can also be added here on this board. So as you can see, the development of this board is really simple. You just need to place some connectors, route the signals to the board-to-board connectors, and you're done. That saves a lot of development time and costs. So that concept offers significant advantages, particularly in projects with medium volume quantities. Now let's dive a bit deeper into the features of the phyVIP baseboard and what's on the board. First, we have the SOM module with the i.MX95 or i.MX8M Plus processor, the RAM and flash memory, of course. Then we already have the complete power supply for the system right here on the baseboard. That's a wide range power supply that can be powered directly by input voltages from 12 volts to 36 volts, which should fit most applications. But what if our application has specific requirements regarding the power supply? For example, it is requiring specific filtering to meet certain standards, or what if it is supposed to be powered by power over Ethernet? These specific adaptations, like a filter, for example, can then be placed on the connector board, while the rest of the power supply is already on the baseboard ready-made. Next, the phyVIP baseboard has an optional AI accelerator on board. This is not an M.2 module. It is really integrated on the board. So we have a stable industrial design, and it makes the design simpler in terms of heat dissipation concepts, since all the chips are on the same PCB side. This targets AI on the edge applications that require more inference performance than it is already available in the processor's integrated NPUs. So on the back side, we see the two connectors for the camera modules on top, the board-to-board connectors to the connector extension board, integrated Wi-Fi Bluetooth adapter, micro SD card slot, and the TPM chip, which helps to fulfill the upcoming requirements of the Cyber Resilience Act. Now, this is a short overview over the signals we have on the connectors to the connector expansion board. We have the power supply input, also a power supply output for components on the connector expansion board. Then typical interfaces we need in applications, Ethernet, USB, CAN FD, also interfaces like UART, SPI, SQRC, GPIO, and so on. And even PCIe, display audio if you would need that in your application. I don't get into details too much here. You will get the handout. The handout has some more has some extra pages, some more detailed information here if you want to get deeper into this. Now, AI on the edge, which becomes more and more important in vision applications, as we all know. I already mentioned that there's the option to have AI accelerators on the phyVIP board. What we have observed here is that at the moment, for many customers, it's hard to estimate how many AI resources their application requires. Others might plan to start with moderate AI support and extend that later. And this made us to design the phyVIP as a scalable AI platform. So we can offer different levels of AI acceleration here. The basic level would be to use the internal NPUs of the processor, which would give us 2.3 TOPS with the i.MX8 and Plus. The i.MX95 is about 4 times faster because of more internal efficient design. And if we need more inference performance, we have a phyVIP version which has an Halo 8 NPU on board, which gives us extra 26 TOPS. Or even with more performance, a version with an NXP Era 240, which is also suitable for large language models with 40 TOPS. And this scalability allows the system designer to upgrade the AI performance of his design without any redesign of the specific hardware. So to wrap up a bit at the end, what remains for the system engineer? It's just the design of the project-specific connector expansion board. So this concept offers high flexibility on one hand and low complexity at the same time. So in best case, customizing is just limited to simply customizing the connectors and maybe the power inlet. But it's also flexible. Additional features can be added on the custom board too. You can design this board by yourself. There's a development board and reference design available. Or of course, you can also use the Phytec design service to get your custom board design. Now, we believe that the phyVIP concept can save up to 70% of development costs and time compared to a fully custom design. So in summary, the vision integration platform accelerates the design from prototype to mass production. Now, it's a future-proof platform because of several scalability options in terms of processor features and AI support. It is an industrial-grade design that can go directly into your end product. Additional components like camera modules are available off the shelf. And on the software side, Phytec offers a comprehensive BSP support, development kits, reference designs. I'm at the end of my presentation. Thank you very much. And before it's time now for your questions, we have prepared a question for you. We would like to know which of the different aspects of the phyVIP concept would be most relevant for your next project. So thank you very much. And Peter.
I've already started the survey and people are a little bit shy answering the questions, but there's no wrong, there's no right. We'd like, now it's a little bit of everyone. So I think I give you 5 more seconds. 4, 3, 2, 1. Anyone who made a last answer? So
yeah, we're really curious about what is the feature that
and the results
that is for you most.
Tech Talk Shuri is or are. Do you see them? Less development costs and effort, faster time to market are the winners.
Oh, thank you very much.
So, and now, of course, it's always also time for questions. So if you have any questions, just use the Q&A chat or the chat. And first question is, for which applications does this new concept really make sense?
Oh, good question. Actually, there is no specific application or specific market. The idea that you can tailor the phyVIP platform with the specific specific extension connector board makes it basically suitable for a lot of markets, a lot of application, whatever you can think about.
Hmm. And this is your concept also available with other processors beside the NXI?
Yeah, that is also important because we're talking about future-proof concepts and things that you might want to use in a couple of years. You want to upgrade in a couple of years. So the processors are on board of the SOM, the computer module, and we are using the Phytec FPSC standard here for the phyVIP. Simply said, FPSC allows to interchange the SOM modules within a given feature class. And like we have already here, the option to upgrade from the i.MX8M Plus to the i.MX95, you can think about other SOMs, other modules in the future, and you have the same platform still, but different processing features.
Hmm. Do customers have to develop the custom connector board by themselves, or are you helping them?
We can first, you can do that by yourself if you like. We would help you. We have um, a lot of services that like a schematic review or whatever. But on the other hand, if you don't want to design that board by yourself, we have a design service. We have design engineers at Phytec. We have our own production facility in Mainz, here in Mainz, Germany. So basically, you can get the whole hardware from us, like
And
one-stop
how
shop.
long would it take if I would use the Phytec design service?
Depends on how complex your design is. If it is like really a simple design, just some connectors, some things that we probably have already in our schematic database, design phase is probably 3 to 4 weeks, plus then the prototype service.
So Martin, thank you very much. I will see you at the final Q&A.